Okay, this is the last of the screencast videos that I've prepared, and it looks at some additional questions which was not covered in the other videos. Okay, now the first one is the specific heat capacity, and the next one we'll look at is limiting reagents. Okay, this is the first question. We want to know how much of energy or heat energy is required to raise the temperature of 250 moles of water from 20 to 100 degrees Celsius. Okay, I'll give you a moment to just pause it here and think about the question. Right, when working with a question like this, we need to know what the specific heat capacity of water is. Okay, you can find that in data tables. Then you also need to know the mass of the water and what the temperature change is. And there's an equation that relates the heat energy equal to specific heat capacity times the mass times the change in temperature, and you just substitute in the values and you get your answer. Okay, you would notice that for the mass of the water I put 250 grams. Remember, 250 moles is the same as 250 grams of water because the density of water is 1. Okay, as you see, this gives us 83,600 joules of heat energy that is required. Also note that I've put in units into the line before that, and you can see the G to the -1 will cancel off with G, and the degrees Celsius to the -1 will cancel off with degrees Celsius. Okay, and we can convert the 83,600 joules to 83.6 kilojoules. As you see, that gives us 83.6 kilojoules. Okay, now we have a look at limiting reagents. Okay, have a look at question 2 and then look at question 2a. Actually, it should be question 2a, not question 1a. We need to find the limiting reagent. So what we've got, you can read up there, but pay attention to the balanced equation because we'll need that as the starting point for our solution. Remember, with questions of this type, the first thing we need to do is use the mole ratio of the balanced equation. In this case, because I'm dealing with the HCl and magnesium, I make up my ratio according to the reaction stoichiometry. I got 1 part or 1 mole of magnesium reacting with 2 moles of hydrochloric acid, and that's why we end up with the equation we have. That's the first step. Okay, now the next part is we want to because I've got number of moles of magnesium on top, I will leave that as what I need to calculate, and then the number of moles of HCl, I'll use that as what is the given information. Okay, it'll become more clear as you see the rest of the solution. Okay, now if you follow the rest of the solution, you see the number of moles of magnesium is equal to the number of moles of HCl times half. Okay, and the number of moles of magnesium is 32 times half, which is equal to 16 moles. Now what does this tell us? This tells us that if I use 32 moles of hydrochloric acid, I would need 16 moles of magnesium. But what do I have? I have 18 moles of magnesium. That means I've got extra magnesium. So if I've got extra magnesium, so it means that magnesium is in excess. So if magnesium is in excess, it would mean that hydrochloric acid is the limiting reagent. Okay, and I think we are done. Okay, now you can follow the more detailed walking and the writing and the different boxes to show how I've arrived at the different parts. Okay, so I hope it's clear now, and that will be all for the revision for the Unit 2 year-end exam. So all in all, there's about, I think, 7 videos put up. So please make sure you go through all of them. Very, very important. Thank you.